much immutability is enough. So take it away.
So I assume all of you are Java developers, right? Not most of you, but all of you. That's perfect. Me too. So I happen to be here in your country, in your city, because tomorrow is the conference where I'm going to be speaking. Probably you've heard about it, called Conference. And but it's not going to be about Java. But today we're going to talk about Java mostly and immutability. So it's going to be quite opinionated talk. So I will give my personal opinion about the situation. Probably if some of you know me, then you probably read a lot, like a few of my articles about that stuff, how I understand object-oriented programming, and which probably is different from what you read from other books in Java, from what you've seen in the code you write, and from what the whole industry is thinking about Java. I think it's a little bit different. And I'll try to convince you that there is more better sides in Java than we have now. And immutability is one of them. So it's going to be 22 slides, quite a lot. But I've heard that it should take 1 hour. That's why I've made so many slides. But I'll try to jump, fast, not to take too much energy. So let's get straight to the topic. First of all, I want to define what the object is. Then I will explain you what immutability is. Then I will show you a few examples of why immutability is so good in Java and in any language in general, technically, like technical reasons. And then I will try to show you the philosophical reasons and more important reasons than just technical reasons. And show you how I'm using immutability and why I think the immutability in general helps us to design better software. And then there's going to be questions probably. So first of all, the object, what I think the object is. And how we misunderstand object in general, in OOP, Java, in all these languages. I believe that an object is, the typical misunderstanding is that we think that an object is a bunch of data elements, like a couple of data data properties, and then a number of procedures attached to them. And that's what I think is wrong. I believe that an object is actually a representative of some entity or some creature of the real life. Let's take, for example, an object of class file. So file in Java, java.io.file, is a representative of a physical file on disk. So that's how we should understand object. So an object is not just a bunch of, again, a bunch of procedures and some data attached to these procedures, and which we can call and get some results. It's a bigger thing. It's a representative of something which stays outside of our software, outside of our scope of visibility. So we have a scope of visibility where this is the scope of visibility. So that's the piece of code where the F is the object. The F is visible in this scope of visibility, and the F is a representative of a physical file on disk. That's the definition of an object, which is really important to understand before we get into immutability. That's a big difference. The traditional definition of an object is the traditional definition in many languages, in Java as well, is that an object, again, is a number of functions, methods, or better called procedures, and then some data which help these procedures to manipulate. Like in this case, we can say that this picture.jpg is data encapsulated in the file, and the lengths or delete are the procedures which manipulate on the data. But that's just technical definition. It's not really right. The more global, the more conceptual, and a way better definition is that the picture.jpg is the coordinate of a real file on disk. And the lengths and the delete are the behavior our representative exposed to us. So the file is like, let's say I'm a file and the physical file is over here. So you talk to me and I'm going to talk to this file. And this picture.jpg is the coordinates. I know where the file is. So when you created me, you gave me the coordinate of that file, and it helps me to connect to that file. That's a definition, which I think is important to understand before we can continue. And what is immutability? Having in mind what I just said. So immutability in that sense means that I am, as a file, I am loyal to that real physical object on disk. So when you created me, you gave me the coordinate of the file on disk. You gave me this picture.jpg. And I stay with this picture forever. So you're not able to change the location of that physical object. So you created me, you cannot change it later. I'm always loyal to that object. That's why I'm called the immutability is actually loyalty. So the object file f is always attached to one physical thing, or one physical creature, of one entity of the real life, of the real world. So it's always loyal to that physical thing in the real world. That's what immutability is. That's what I believe is the right definition of immutability. And mutable objects are objects which are able to change the encapsulated data. So you create the file in Java is immutable. So you create the file, you say new file, picture, JPEG, and you can never change this picture, JPEG. If you want the new file, you create a new object, but you can never call a setter, for example, and say set new location of the file. So the file is immutable. But there are not so many immutable objects in Java. Most objects from JDK are mutable. So you create them, you instantiate them, and then you call setters or some other methods which actually are able to change the encapsulated data. And in that case, I believe these objects are not loyal to their physical, to the things they represent. That's the philosophical definition of immutability. But now let's get to the practical things of, did I make it clear or not? Like, we're on the same page, or it's okay. But it does sound quite theoretical, right? So it's not really practical. But that's what I wanted. That's how it should sound. That's how it should sound. It should sound theoretical, but that's important. So, but you probably understand what immutability means in technical things, like technical and a low level, right? So immutability means that you can never change anything inside the object. So all of these properties are final. And I'll give you an example. So here is the immutable object. It's a good example of an immutable object. Book. So we instantiate, well, this is mutable, sorry. This is a good example of a mutable object. So this one is not loyal at all. So we create it, we give nothing to it. There is not even a constructor in here. So when we create an instance of this class, then it's going to be 0 for the ISBN, and it's going to be null for the title. So it's not initialized at all. And then we need to initialize. Then we call setters. We set the ISBN and we set the title. So we configure the object. There are basically two steps for mutable objects. First, you instantiate them, and then you can initialize them. Instantiation and initialization. For immutable objects, there's only one step. You only create it once, and this is called instantiation, and there's no initialization after that. There's only one step, which is instantiation. So this is the example of a mutable object, which is not loyal, because we can always change the title, we can always change the ISBN. So we create the book, we set that this is the ISBN for the book A, which is on this bookshelf. And then later, in 5 minutes, we say, no, how about you start working with that book on another bookshelf? And then 5 minutes later, you start working with another book. So the object is not loyal at all. It changes the coordinates. We can change the coordinates in any moment of time. And it's not really good. I mean, loyalty is good, not being loyal is not good. So that's an example of the mutable object, and that's the counterexample of the same object, which is immutable. So like you saw before, these are a bunch of setters, which we can call during initialization step. And this is the constructor which we create, which we call only once. So if we don't like that book anymore, if that book points to the book on that bookshelf, and we need to point to another bookshelf, so we just create a new book, a new object of class book. And that's immutable. In that case, you can see the difference. There is a modifier called final, which is attached to both properties. The ISBN is final, the title is final. So we can never ever change them after the object is created. So we cannot even introduce the method here, which will be able to set them later, because that's going to be against the compiler will fail, and it will not allow us to compile the class. So we cannot add any setters to this class. Do you understand the difference? Mutable, immutable? And now let's get to the technical advantages of why mutability is good and why immutability. Basically, there are 4 reasons, 4 technical things, which you can read in any book, so I can just go through them. I'll give you 4 examples and show why immutable object is technically better for most cases. The first reason is thread safe. So this is the most obvious, everybody talk about that. Immutable objects are thread safe. Here's an example. Do you know what thread safe is? You probably know because you work with multiple threads, right? Well, I didn't know that like years ago. But it's not that easy to clear what the definition of thread safe is in Java, because but at least we have to say that in the thread safety means that if many threads at the same time manipulates with the object and calls some methods and tries to do something with the object, then the object is not gonna crash unexpectedly. So the object may crash, may like throw an exception, may say that I'm not gonna accept something from this thread or from that thread, but it's never gonna crash in a way that is unexpected, which is unpredictable. So the object always behaves in a predictable way. So let's look at this example. The class array list, is it thread safe or not? It's not thread safe. So the array list is expected to be used only from one thread. So only one thread can instantiate the array thread and then call its methods in some order. But if you try to access this object from another thread at the same time, and then the thread A gonna call method add, and then the thread B gonna call method add, and they will do it at the same time in parallel many times, you can try it and you will see that at some point the object list of class array list gonna crash somehow. It's gonna be some exception, it's gonna be some unpredictable behavior, so it's gonna be something which you're not gonna understand what's going on. Maybe it will be in some strange state, so there is no guarantee of what's gonna happen, because it's not designed to be thread safe. Because it's mutable. Because the object of class array list is mutable. With the immutable class, there's no way to be thread non-safe. It's always thread safe, because none of the properties which are encapsulated can be modified. They're all final. So it means that no matter how many threads are calling me, I'm not touching my encapsulated objects. I'm not touching my data inside. So that's why no matter how many threads are accessing me, I'm always safe. Because I'm not changing anything, basically. Because the problem with the array list is that you call these add methods and they're trying to modify something inside. They have the array inside, which is the physical array, Java array, and they have probably the pointer, which shows what's the end of the array. When you're trying to add something, it tries to modify the pointer. So they modify the array, they modify the pointer, they actually modify the data inside. And it's difficult, well, it's impossible to do it in parallel threads. You need some synchronization, but they don't have any synchronization inside. That's why they collapse and they clash, and these parallel threads, they actually have problems between each other. And if that array would be immutable, that would not happen. But in that case means that immutable objects always, when you're trying to modify something, they don't modify anything inside, they're always creating another object. So when you have a list which is immutable, let's say you have a list with 5 items inside, and then you want to add one more item, then you're gonna create a new list. So the previous list stays the same. But then you say, add me one more item, and it's gonna be another list which has 6 items. Then you say, add me one more, it's gonna be another list. So you're always creating new objects. You don't touching the object which was created before. And that's the beauty, that's the problem, that's the an overhead, obviously, because you're always gonna copy these objects and make them more and more. But at the same time, it's thread safe always, because you're not touching the data at all. You only touch the data when you instantiate the class. When you make the object, when you make an instance of a class, that's the moment you touch the data. But later, nothing can happen. So that's the benefit number one of immutability, is thread safety. Clear, or need more information? Yeah.
When you have an array and you add an element from one thread and you add another element for another thread, you're going to create a clone of that array on thread A and have 6 elements in that one, and on thread B you're going to have another array with 6 elements, but the 6th one will be different, will be X in the thread A and it will be Y on thread B. How does that reconcile? Exactly.
Good question. So I'll explain the question again. So let's say we have 2 threads and we have one array, one list, and the list has 5 elements. And then this thread wants to add 1 extra element and to do something with the list, which has 6 elements now. And then another thread also gets this object, which has 5 elements, and it wants to do something again, and wants to add 1 more element and do something with the list, which has 6 elements. There's 2 parallel threads. How are they going to synchronize? Probably not how. There is no way to synchronize that, because they don't know about each other. Well, if they don't know about each other, then they will deal with 2 different lists from that moment. So there's going to be one list here and a different list here. And there's going to be a third list here. So we're going to have 3 objects. One, the original one, and 2 copies of them, which are bigger. And then they will deal with their own copies. if they want to synchronize somehow, that they need to find a way, these two threads need to find a way how to share this object which was created by one of them. So it's going to be their problem. They need to synchronize each other, they need to find a way how to share this next object, this object which has 6 elements. It's going to be a different problem. It's a good question, yes. But for the list, it's perfectly safe, because the list doesn't care about this manipulation. The list doesn't care about this synchronization. It just stays with the 5 elements, and that's it. So nobody's going to break it, nobody's going to touch any data inside. So that's the number one advantage of thread safety. The second thing is called failure atomicity. Who knows what it is? Oh, perfect. Then I'll explain. So this is a thing which is quite difficult to debug, quite difficult to catch, but it happens a lot with immutable objects in not only in parallel. It's not about thread. It's not about multi-threading. Just happens. Look at that example. Let's say we have the list, which is called numbers, and it has an array and it has a position, just like an example we discussed. And we have a method which is called add. So we want to add new number there. We want to add new number, and what do? The first line we increment the position, and then we check whether the x is positive, because we want to accept only positive numbers. And then if it's not positive, we throw an exception. Let's say this is our example. And then if it's positive, everything is good, then we put this number into the array, and basically that's it. So what is the problem with this function, with this method? The problem is that if the x is less than 0, then the state, the situation with this object is going to be quite strange, because the exception is thrown, but the position is already incremented. So we leave the object in a really unpredictable situation. I mean, in a broken state. So the mistake which happened here actually broke the whole picture, well, broke the state inside the object. So now we have a position which is incremented, but the number was not added. So if I call this method many times, giving these negative numbers there, the position will go up, but the array is not going to be filled. So you understand this is not what we want. So this is called, the definition of that is called, there's failure atomicity is broken. So we need to be atomic. All our objects need to be atomic. So which means that if I call you, you either do this for me, or you throw an exception, but you don't change anything if you throw an exception. So you don't try to do it and then throw an exception in the middle of this try. You need to either finish it completely, or crash and throw an exception and don't do anything. But in this example, you tried, you started, you incremented the position, but then you gave up and you never finished. So you left yourself in a broken state. And that's bad. That's a problem with mutable classes, because this class is mutable, and of course this code is not perfectly written. You can just move this position incremental line below the if, and everything will be fine. But I'm showing this just to demonstrate that sometimes we just forget about that. In this example, it's just easy. Just 3 lines of code, you just put them in the right way, and everything will be good. But if there's going to be 50 lines of code, you don't know where exactly you may throw an exception. You may start doing something, and then tomorrow you you remember that we need to do some extra check. You put it at the bottom, and you don't remember that in the front of the method you already changed something. So you always need to remember how to keep this failure atomicity with immutable objects, and it's not so easy sometimes when the objects are quite complex. With immutable objects, there's no question like that at all. Why? Because we don't change anything. With the immutable objects, you don't touch this position. You're not going to touch the position, you're not going to touch the array. All you do when you want to add something, you create a new list. You fill it with some data, and then you return it. So the add method with the immutable numbers will always return numbers. So here, it's going to be not void, it's going to be numbers. So I have these numbers, and I say, how about you add one more number to yourself? And it says, no problem, I'm going to create you new numbers with this x and return it back to you. That's how immutable lists, or whatever, all the immutable objects they work. They don't modify themselves. They stay final, they stay solid, they stay immutable, non-modifiable. Every time you want to change something, they prepare a new object for you and return it back and say, this is the one for you, which I just modified, made the changes you wanted, and now you can use it. So the failure atomicity will be 100% Not 100%. We may still have problems, but with the mutable classes as well, let's say we work with files on disks or the database. So you call me, I start, for example, the transaction, I do some modifications on the database, then I crash, and then I still return. I'm still immutable. For example, let's call the file the class file, which we discussed before, the Java file, java.io.file. It's immutable, but still it works with the disk. So there could be potentially the situation when you call the method delete, for example, and I go to the operating system, I start deleting, I can't delete because of some reasons, then I return it back an exception, but something was modified on the file system already. That may happen, but that's a problem for the different discussion. But if we're talking about simple objects, primitive things, which just work with memory, and we call them immutable, then this failure atomicity is enforced. That's the word. Number 3, the advantage of immutable objects. No identity mutability. Who knows what it is? Perfect, then I'll explain. Look at this example. We have a map, and we have a class, we have an object book. I'm sure you understand what it does. So we have a hash map, and then we get we have a book, then we set the ID for the book, and then we add this book to the map, and then we set the ID to 2, and we add this book to the map again. And let's say the book inside implements this the equals method and hash code based on the ID, which is logical, right? So the book has an ID, and based on this ID, I can compare myself to another book and say, if my ID is 1 and your ID is 1, then we're the same book. So if my ID is 2 and your ID is 1, then we're not the same book. So what is happening here? In this case, in the end, we're going to have 2 books in the map, which are the same objects. So it's going to be the same book here and the same book there. But these books, they're going to stay together, but I don't even know exactly what's going to happen. But that's really unpredictable situation here, right? You can smell it from the code, right? So we're just abusing the way these objects should be identified. So first of all, it's one book. It looks like the book number 1. Then we put it to the map. The map remembers that this is the book number 1. And then the same book changes the identity and says, no, I'm not a book number 1 anymore. I'm book number 2. And then we try to put this book number 2, which is actually the same object, into the map. So what's going to happen? The map will compare them, but they are the same. So it's really unpredictable, and this is called, the name of this problem is identity mutability. So we mutate the identity. We're not just mutating the data, which is half of the problem. We're mutating the identity. So if we can, with mutable objects, if we allow them to change their numbers inside, their data which they encapsulate, then we basically allow them to say who they are, to change their identity, and to change the way they represent themselves. Today they're number 1, tomorrow they're number 2. And it's difficult for the code which already remembered that the book is the book number 1. So after the call to map.put, the first put method, the map remembered that this is the book and the name of the number of the book is 1. And then later we call again, and suddenly this is the same book, but the number is 2. It's going to be confusing, and the state of the map, in this case, I don't even want to think what's going to happen. But if you take more of these examples and try that more, it's quite a typical problem, and it's well described. Google for it. Is it clear? This problem, yeah? So this is problem number 3, which immutable objects solve. Because with the immutable objects, the book number 1 is always going to be book number 1. You make it book number 1, you save it, you transfer it, you do whatever you want with this book. It's always book number 1. It's never going to change the identity. It's never going to say that I'm book number 2 suddenly. And the problem number 4, the last one, called that side effect. So immutable objects are side effect free. And let me show you the example, the code. So look at this code. We have the method called print, and I'm giving the book to the method print, and the method actually prints the book and says book ID is book get ID, and then it says book set ID by mistake. This method print is created by somebody who probably did it by mistake or forgot why it was done, but it was done. So we have the code, which we have this method print, which actually has a side effect. So every time I call the method print and I give you my book, I need to know that that method print is going to change something with my book. It's going to do something with it. It's not going to just print it, but it will change the ID. By mistake or not by mistake, but this is called side effect. So the real purpose of the method print is to just print the book ID. But instead of just printing the book ID, the method does something else, which is the side effect. In this example, it's quite stupid, right? It's just primitive example of this side effect, but they could be way bigger. When you pass the mutable objects to somebody, you are afraid that that somebody can do something with that object. That it's possible technically. So that method print or somebody else, we don't know what's going to happen inside the method print. Our object goes through these methods and deeper somewhere, and we are really afraid of who's going to touch it and who's going to call this set ID or any other setters or any other modifiers which will actually change the object. So we don't want that. We don't want that side effect. And immutable objects, they solve that exact problem. Because if the object is immutable, then I'm not afraid of giving you my object no matter who you are. I create the book, I set that the book number is 1 and the title is ABC, and that's it. I give you the object, no matter who you are, how you're going to use it, you're not going to change anything. And this is way safer for me as a programmer to work with objects, because I know for sure that they're not going to be modified. Don't we need to open the, because you'll start getting oxygen. Let's open the window, I think it's going to help. Me too. Just something. We don't need enough oxygen. We don't have enough. Oh, perfect, thank you. So, there are actually 5 reasons, not 4. Sorry, my mistake. So that's reason number 4. And then there's another one which is number 5. So, are we clear about that one? The side effect. So you understand what it is. Maybe the example is not really practical because it's kind of obvious that this is just a mistake made by the developer of method print. But in general, the side effects could be everywhere because we forget things, we don't know what the real purpose is, we may do something for our own purpose, we may do something for us temporary. Let's say this is the method and they give us some objects. They give us some object. Let's say they give us an object and we change something inside the object temporarily to do something with it. And then we want to change it back. Let's say they give us the book, we temporarily change this ID from 1 to 1 to 3, do something about it, and change it back to 1. And then we forget to change it back. So it may happen as well. So if the object is mutable, we can temporarily modify it somehow and do something about it, and then forget to return it back to the state where it was before we got it. That's called side effect. And with immutable objects, it's not going to happen at all because they're not modifiable. You can change anything. So we can't trust everybody. And the problem number 5, which is temporal coupling. Again, who knows what temporal coupling is? Perfect. Then I'll explain. Let's look at this code. We're trying to make an HTTP request. The request is an object, we set URI, which is going to be requested, and then we set the method to get, and then we add the header, which is this one, and then we say, okay, fetch the body. It's really important to, in this particular case, maybe it's not so important, but in general, in this code, we need to remember that we need to first of all call these 3 methods, and then call fetch. So we cannot call fetch before we call these 3 methods. So I'm, as a developer, I cannot move these 3 methods below the line number 4. They need to stay in this specific order. So they are coupled together by the order. This is called temporal coupling. So they call by the time of when they should be called. They always should be called in that order. Well, these three methods probably can be, the order of them can be changed. Probably, we're not sure. We don't know what's inside this request method or the request object, how it's designed. Maybe it's not possible. Maybe we have to set the URI first, and then we need to call the set method. Maybe it's not possible even to change these 2 lines. We don't know. But we definitely can say from this code that the line number 4 cannot go above, and we cannot call fetch until we configure the object. Most probably. But if this code is way longer, let's say there are 50 lines, and then there's some configuration happening, and then some calls to the objects happening. So it's really going to be a problem in the future to tell what exactly is the right order, how they should be called. The number 1 goes first, or the number 1 goes next, we don't know exactly. Because they are mutable. So we need, because there are 2 steps, like I said before. The first one, instantiation. So somewhere up below, this request object was instantiated, and then now we are initializing it. And then it starts to live, starts to actually do something for us. And that's because we have these 2 steps, instantiation and then initialization. That's why we have this temporal coupling. We don't know exactly how this initialization should happen. We need to go into the code, we need to understand how it works, and it's difficult for us to maintain that. We don't want to touch this code because we don't know what's going to happen. If I move line number 2 above line number 1, will it work or not? It's not really clear. I can't say, because this information is not available for me. The compiler will still compile, but maybe it will break. So this is called temporal coupling, and it can happen because the object is mutable. Because the object expects us to change something with inside the object after the instantiation. After the object is created, it expects us to call these extra methods and configure it somehow. With the immutable objects, it's not going to happen at all, because there is going to be no setters at all. You just create an object and it's ready for you to work. You just make the request, you provide everything through constructor, and then it's immediately ready for you to work. In this case, it's not ready to work. So probably the request, which was here before, it was not ready for anything. It was just a request, just an empty object which was just created, not configured. And then we configure it, and then it becomes ready for us. That's how mutable things work. The immutable, it doesn't work like that. The immutable is immediately ready for work. After the constructor is called, we have an object which works for us. So that's 5 reasons, which are technical reasons why immutability is better than mutability. But this is not what I want to talk to you about today. This was just a preamble, just a definition of why immutability, technically better, but that's not about it. This is the main thing I wanted to say. The immutable objects are the objects which we can trust. That's the main thing. So the immutable object, like I said before, it is always loyal to the real thing from the real life. The object is loyal, and that's why we can trust that thing. We can trust that object. So for us, it's not anymore a temporary storage of data, like the mutable things. The mutable object is just a temporary storage of information, which we don't really trust. We know that it's coming to us with some data encapsulated, and we're just trying to get that data as soon as possible out, manipulate with this data, and maybe return something back, and forget about this object. This is how we work with mutable things. They come to us, we understand that they're just bags of data, just collections of data, just basically baskets of data, and we're supposed to get that data out, manipulate with the data, and return it back probably, or just throw away the object. We don't trust our objects. We don't understand them as real representatives of real things. We don't understand them as self-sufficient and solid and living organisms. We take them as just storages of data. So we don't trust them, that's the point, because they are mutable. Because we don't trust them because we know that anybody else and somebody else and some other thread or somebody else from another piece of code or somebody else from this side effect, we don't know, can basically inject something there, and nobody treats them as solid structures, as structures which are created and they stay blocked and they stay locked for the whole life. We understand that they have a lot of holes, they have a lot of points where other code can break in and change something inside. They can call these set methods, set whatever, setters, which can modify what's inside. So we understand that, and that's why we don't trust them. We don't trust them, and that's why we treat them as just data storage, not just real objects. And that's why, because of that, we're thinking procedural, not object-oriented way. We are thinking like we are the procedures which are getting some data from these bags of data, which we call objects by mistake. So they come to us, we take as much data as possible, we manipulate with the data, and then we probably return that data somewhere else. So we don't give them control. We try to control ourselves. We try to keep all the control inside our code instead of letting our objects to work. That's mistrust is coming from mutability. So the mutability is what generates mistrust. And that leads basically to 2 problems which I'm going to describe, and then we're done. But am I clear about the trust thing? Probably not, but I'll show you two examples and maybe you'll understand more. But that's really important. That's what I want to say about this. All these technical things you can solve them without immutable objects. All these failure atomicity, you can solve it even being mutable. This thread safety you can achieve with mutable objects. This temporal coupling, you can probably solve it somehow with the good documentation. So all these technical things, they are solvable, but immutable objects make it better, make it nicer, make it easier, make it like your life make simpler if you make your objects, most of them, immutable. But I want to say that all of your objects should be immutable. That may sound strange, but I have a lot of experience of writing Java code with only immutable objects. I even have a web framework, Java web framework, which contains about 300 classes, objects, and none of them are mutable. So this is the entire web framework, like Spring. So it does everything. It's even, it even contains the web server. So it's the web framework which you just use. It's just one jar file, no servlets, nothing. You just use one framework, and it builds the entire web application, which just starts and runs the web server. And it's about 300 classes, and all of them are immutable, all of them. So it is possible. It's not utopia. But I'm saying that you should try to make more of your objects immutable, more. It's going to be difficult because Java is not designed that way. The Java is not really perfect with dealing with many objects, because if your objects are immutable, then you will have to make many of them. When the object is mutable, you basically can reuse it and reuse it and reuse it. For example, Android SDK, they officially recommend us to use mutable objects and to reuse them as much as possible. Because they know that on their platform, on the Android, creating a new object is time-consuming operations. It's then going to be garbage collection afterwards. It's a lot of extra hassle around basically calling the functions and calling the operations we need to do with this data. So that's why they say use static methods, don't use many objects. If you create an object, try to stay with this object for the whole life of your application and reuse it and reuse it and reuse it. But that's just a limitation of their platform. But this is not how object-oriented software should be designed. We need to make many objects in a true object-oriented world. Many objects and never reuse them. If you don't like the objects, throw it away. So you create it, it's immutable for you, it's the way it's designed, it's the way it's created, the way it's instantiated, and you trust it, you know that it's never going to change the state, it's never going to change what's inside. You stay with this object for a lifetime. So my point is that all objects should be immutable. Not as much as possible, not as many as possible, but all of them. Whether you can achieve that in Java, I don't know. You can try, but we have achieved that in this web framework, which contains, like I said, all immutable objects. So there are basically two problems, two things, not problems, but two things which you will get if you really go for immutability. And these are not technical things; they're the theoretical things. First of all, is you're not going to have monster objects anymore. So the monster object is something which has tons of methods, encapsulates a lot of things, and does a lot of features and provides a lot of features. I wrote an article on my blog about that example. So I took a library which is called Apache Email. It's a library, open source library for sending emails, the Java library, and there is a class in that library which is called email. So you're supposed to send an email, and you create an instance of class email, and then you configure it with these setters. So you call these setters, and they have like about 50 setters or something. So you configure this class, and then you say send. And this whole class sends the email for you. So that's a perfect example of not object-oriented design. It's a perfect example of how mutable class actually lead to a bad design. You can obviously understand there are about 2,000 lines of code and about over 150 methods in this class. So how is it object-oriented? I don't know. So on this article, I redesigned this thing, and I created my own library, which does exactly the same. It sends email from Java, but it's done in an object-oriented way. And it contains about 50 different classes. And each class has about like 20, 30 lines of code. But there are many of classes. So they all collaborate to each other, and when you create and when you want to send something out, you create a complex object composing together these different small objects, and then you get the email, then it sends out. The immutability helped me to do that. You can read that article. It says how immutability helps on the blog. And this is how it looked before. But this is not about email, but I'll give you an example. I'll explain what the monster class I mean. So let's look at this. Let's say we have a task and we want to read the CSV file from the disk. We have the CSV file on the disk and we want to read that file, and we create a reader, and then we configure this reader and we say the file to read is this. The format is CSV. The column to check, the column we want to get is number 3. And then make sure that all letters are capital. And then make sure that you cache, so you don't read it twice when I call you twice. And then we create that, we configure this class because it's mutable, so we put these features inside. This is how we think when it's mutable. This is how we design, this is how we used to design stuff. So we configure them, we say, okay, give me that lines, read them from there. And this is procedural approach, and this is the monster class. And it's possible to do it because we have mutability. So the mutability pushes us that direction, to the procedural thinking. Because they're just saying, if you have a class, you're allowed to add more functionality to it by just introducing this configuration, these setters for configurations, for configuring it. So the class grows inside. It's just natural for us, instead of making new classes, we just grow the size of the class. We just introduce new stuff into it. And that's how probably Apache created their email class, which is 2,000 lines of code. They probably started small. I can imagine that. They started small. But then eventually they got new requests, new ideas, new features from people. How about SSL? How about changing the recipient of the email? How about changing the title, the body? How about making it possible to configure and add new, I don't know, whatever, flags, everything. So they started to add new features to the class, making it bigger and bigger and bigger, and it becomes a monster class. With the immutable class, it's not possible to do that, because you cannot make your class, if it's immutable, you cannot make it huge. It's just technically it's not going to work for you. I mean, you will have big problems with the constructor. That's first. You're not going to be able to make the constructor with 15 parameters. It will look ugly, and you will immediately realize that you're doing something wrong. So when you need to, like in this email, for example, the email class from Apache, they encapsulate, like I said, about maybe 30 or 40 different things inside. So they encapsulate a lot of things. It's a huge list of properties in the beginning of the class. If that would be immutable, you have to encapsulate all that into one constructor. So your constructor will be huge. And it's going to be so ugly that you will immediately realize that I'm doing something wrong. I need to break it down into smaller pieces and make it smaller and make it, if that's immutable. Because, of course, in immutable classes, you cannot inject anything later, like we discussed. We need to pass everything through the constructor, and then the constructor will grow. So, so these monster classes, they're not going to happen. If you think immutable. If you think immutable, all your classes will be small, really small. Like in our example with the framework, web framework I said. It's called Takes. You can check it later. We have about 300 classes, and the biggest class we have is probably about 50 lines of code. 50 lines. So all of them are just 2 pages of text, maximum. Because we cannot make them longer. If it's immutable, it's difficult to make it longer because you're limited in your functionality, because your constructor is, you cannot put too many things in the constructor. It starts to look ugly, and you immediately understand that you're going the wrong way. So you need to make your classes small because of the immutability. All immutable classes are small, inevitably. So that's one thing about the monster classes. And the thing number 2 is object composition. That's the most beautiful thing I wanted to mention. This is one of the last slides. So object composition is when we trust the object. When we trust it, it's immutable. We trust because it's loyal to the real thing in the real life, and that's why we trust it. Then in that case, we can build structures like this. This is the same task like it was before. So we still have a file, and we want to read that file from disk, and we got to get this. This is CSV. We want to get the column number 3, and then we want to turn it into all caps, all the letters, and then we want to cache it. But this is how your object-oriented software has to be designed. This is called object composition. So you have a small object which is file, and then you compose it into a bigger one. You basically wrap it up into file input stream, and then you wrap it into lines from stream. So this one is already a list of streams. And then you wrap it into the CSV, which gets this one and turns it into a list of streams. And then you wrap it into one column, number 3. So this one is again a list of streams, but it encapsulates the CSV, the list of lists, with the number 3. And then you wrap it up with the all caps. It's again list of streams. And then you wrap it into cached list. And then you get the X, which is an object, which has the properties of what we really need. So this is the object thing, not procedural one, but object. In this case, we haven't called the read method. We haven't called any configurators. We didn't do anything yet. We just composed an object. We just built an object structure. It's a big complex object, not complex, but it's composed of many, many, many levels. And then this final object X behaves like the column number 3, which is converted to all caps, which is retrieved from the CSV, from the file stream, whatever. So this is exactly the same code from here, but this is procedural design, mutable design. And that one is exactly the same, doing the same technically, but that's object design. So in object design, when classes are immutable, we can trust them, we can compose them one into another, because we know that this one is immutable. It's not going to change the direction. We always can rely on it. We know that it is loyal to the real source of data. And this one is also immutable. Well, in Java it's not really immutable, but let's say it's immutable. This one is also supposed to be immutable. And that one, and that one, and all of them. So they are immutable, which means that when we create them, they're never going to change their properties in the future. They're always going to stay loyal to the stuff they encapsulate. And that's why we can't build structures like that. When stuff is mutable, we're getting back to procedural programming, and I'm finishing 1 minute, and we're done, and then questions. So when we're doing the mutable things like that, then we are thinking like procedural programmers, and we need to basically, we don't respect the class anymore. We take it like a storage of data with the procedure read. So we just stuff it with some data and then say, read it for us. So it's not a thing for us. It's not a partner for us. It's not somebody who we can trust. It's just a procedure with a number of data. In this case, we don't call the procedures. We don't inject the data there. We compose the structure. We compose an object which we can work with, and then it starts interacting with us. I hope I triggered some thoughts. I'm not sure you understood everything, but at least start thinking that way. I'm finished. This is my blog. You can check it out later. I posted a number of articles about it. Just Google, search in the blog for immutability. There are probably 3 articles. Just read them. Everything I said today basically summarized over there as well. And now the questions.
Yeah, so the question is related to the fact that there on the latest example, you had some mutable objects because you're using some APIs from Java or whatever.
Yeah.
So what was your approach? You basically took all APIs that you use and wrap it into another object and make it immutable, or how was the approach to convert all APIs that you had to be immutable?
Yeah, that's a good question. Yeah, obviously the question is that Java basically provides us a lot of JDK, which has a lot of mutable stuff, right? And it's probably difficult to write immutable classes when we need to use a lot of classes from JDK, which are mutable, right? So in our framework, for example, we tried, well, sometimes you just can't do anything, and that's why you make your objects, you need to find compromises. So you do use some stuff, let's say we have class, I don't know which one is the mutable class from JDK. Let's say this the input stream. The input stream is immutable stuff, or iterator, for example. Iterator, they're everywhere, and iterators are mutable. So you call them next, 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 and they keep changing their state. So you need to call them, and they always keep changing their state. That's the way Java designed them. They are mutable. And then at the same time, you want to make your list, for example, immutable. So you try to find the compromise and try to use, it's not so easy sometimes, but we are just trying to find a compromise. That's all I can say. But yeah, the problem exists, definitely. So they give you a lot of classes which are mutable, and then you want to design your class immutable. So you still make you try to make your stuff immutable, if possible, and if not, then
It's not really possible, right? To make a class immutable if it has
if it has something which is mutable inside, yeah.
you cannot really,
In some cases, you rewrite this whole thing. If it's really important for you, if you really want to make this your piece immutable, then you rewrite the code from JDK and make your implementation of iterator, for example, which is going to be immutable. But it's not exactly that you have to make everything. It's not always you need to make everything immutable for the. You may have your object immutable for the client, but inside it may have something mutable. Just don't expose it to the surface.
The component, if you make that class immutable, so even though you have mutable attributes inside it, you don't expose access.
Exactly. Yeah. In that case, it looks immutable to everybody else. Yeah. Just don't expose. That's what I'm saying. So don't let people don't let your clients, other classes, other objects think about you as a mutable structure, and that's how you stay immutable to them. How you implement it internally, it's not really important. Internally, you can be mutable. You can modify something inside. You can do whatever you want, as long as for the outside you don't allow them to treat you as a mutable structure, and that's it. That's enough. So what's inside you is not really important as long as you're thread safe, for example. So if you want to be thread safe, if you really want to look immutable, you have to be thread safe as well. So you can't just declare I'm immutable and then they call you from multiple threads and then you crash. So you have to be synchronized or whatever. You have to be safe, completely safe. But how exactly it's implemented inside? Let's say, for example, in this case, the cache list. So this is the class which is supposed to, when I'm calling it once, it goes to the encapsulated stuff and retrieves the data. If I'm calling twice, the second time, it doesn't go below. It gets the data somewhere. Where? So it stores it somewhere, right? So where does it store it? Inside, which means it's mutable, right? But nobody can see that, and nobody can touch the stuff that it stores. So it has some buffer inside. It has some cache inside, which is probably atomic reference, whatever. So it has some storage of data. So you call me once, I go somewhere else, I get the data from the file, I return it to you, and I store it into my buffer, into my storage, in my cache. Then you come to me second time, I don't go to the file anymore, I just get it from here. So what is it? Is it a mutable structure? Definitely. Did I modify something? Yes. But do I look mutable for you? No. Because you can't check this cache, you can control what's inside, you always work with me as an immutable structure. So that's perfectly fine. As long as this cache is synchronized and nobody can, it's multi-thread. It supports multi-thread access. So that's how we use it. We have these cached classes in our framework, in the web framework I mentioned, and we always implement it like that. So we have some buffer inside, some stash inside, where we put this temporary data, but nobody can see that. So from the outside, they don't understand that.
And of course, making sure not to make the rookie mistake of returning the thing and actually in the process enabling the client to change the cache.
Yeah, definitely. Yeah, of course. Yeah, you don't expose that cache. You don't allow your clients to touch the stuff inside.
Even that, basically, could be useful. Like you would have a final instance of something, and you just when you read, you initialize it, and it would be virtually impossible to change, because that would be the implementation. But you have to make sure that that's the case.
Yeah, exactly. Yeah. So that's right. Yeah. No matter what's inside, I think what matters is outside. So from the outside, we have to look immutable. What's inside doesn't really matter, because it's basically the problem of Java implementation. So Java does give us these tools, and we have to work with that. So Java does not allow us, for example, the caching. Java does not have any caching mechanisms from the JDK. Not even from the JDK, from the language. So the Java does not allow us to access the memory directly, like C++. In C++, I can be immutable, completely immutable, and still have this cache. Because in C++, I can store the pointer to the cache in memory. So you instantiate me as an object, you give me some data, you create me, and I immediately allocate some piece of memory, and I store the pointer to that piece of memory. And then when you call me first time, I go to the file, I retrieve the data, and I store it where? In that pointer, in that piece of memory. And you come to me the second time, I get it from that pointer. So all I store here is just a pointer, just a number, just 4 digits, 4 bytes. So I'm immutable. I have the location of the file, and I have the location of the memory. Memory and file. That's all. I am perfectly immutable. In Java, it's not possible, because Java does not allow us to manage memory directly. So they disallowed us to do that, and that's why we need to do this, these tricks. But in C++, that would be completely ideal immutable class. So I have the location of the file, immutable, the location of the memory, immutable. I'm perfect. Java is a little bit,
In Java, you can have final references in an object, right?
Exactly.
And those are Those are the pointers that you
That's the point, yeah, exactly. So it's going to be the final, for example, atomic reference, yeah. Right? That's what you mean?
No, I mean like where you have the book example.
Yeah.
But instead of the string or let's have a string buffer. Just to make
String buffer, a mutable structure, exactly. Because
So you
yes.
have the reference there, but if you make the reference final, it will be like the pointer.
Exactly, yes, yes. Yes, but this string buffer, that's the question. The string buffer is mutable thing. But in C++, it's going to be integer. Integer because integer is the pointer. It's immutable. It's not a reference to the object. It's just immutable number. So in Java, it's a little bit, it may look strange. If you look at the class and they say we are immutable, and then there is a string buffer inside. You may say like, how is it immutable? There is a string buffer inside. There's a mutable structure inside. It's a mutable object. But think about it on the higher level. So if we do not expose this immutability to outside, then it's perfectly all right if we have some mutability inside. I believe that's what we do, and it looks perfectly fine for the clients. They still believe that we are immutable. Like in this case, cached list. Is it mutable? No. We just make it. We encapsulate whatever it is, and it just behaves. But inside, it's going to modify something every time you call it.
Yes, but in your example from the, you have the new lines of new file input string, right, which is not immutable. So if you receive an object that is created somewhere else, you are immutable, and you cannot. So
This one is mutable. File input stream. Yeah.
Yes.
Yeah. Exactly.
It's
Yeah.
somewhere above the new cache.
It is mutable, yes. It is mutable, like I said, this is mutable, but this is, that's a good comment. Yes, in this case, this whole structure becomes mutable because we cannot, because this one is going to behave differently every time we call it, right? So it's going to be, well, yes, this one is mutable in Java, but let's say I'm not using Java class here. I'm using my own file input stream. So I'm just for the sake of argument. So I put it there, but I didn't mean Java IO file input stream. I just meant some input stream which could be immutable.
Could be immutable if it is a file input stream inside the lines of inside the file.
Yeah, for example, like that. Yeah, exactly. Yeah. We are running out of time, I think. But yeah.
What's the performance trade-off? Because dealing with multiple objects is not quite.
Yeah, that's a question. So we see.
Did you measure, let's say, your framework written in a mutable way versus speed in immutable?
Yeah, that's a question. I'll repeat that for the camera. So the question is about performance. So how fast it can be if we have so many objects and that they're all immutable, and every time we need to recreate them if we want to change something. Definitely, it's going to be slower. Definitely, because like I said, Java is not designed to work with many objects. All this garbage collection is a problem, and then the actually creation of the object, instantiation of them is a time-consuming operation. So sometimes in practice, we see problems when we design everything with the immutability in mind. So immutability helps us to design things right way. So the code looks clean and classes are small. And then when we find the problem with the performance in some particular place, then we jump in there and we change the immutability to mutability, something like that. And sometimes we go back to the static methods and we go back to all this optimization recommendations from Android, so just don't use objects. Sometimes it happens because we're dealing with real world. And in this real world, Java is not perfect and JVM is not perfect. So we can't do that. But that should happen only in specific places where when your profiler says that these objects you make too many. So in this case, you optimize it somehow and maybe replace an object with just a static method, which is a terrible design, speaking of design, but it has to be done only once. So you shouldn't start with thinking about performance first, like how I'm going to design my system fast. If you think like this, you're going to create one huge file with 5,000 static methods. That's going to be fast. That's the fastest way. Maybe even one method. You don't even need methods. You just create one big, huge main function, method, whatever you call it, procedure, and put everything in there. That's going to be super fast. But in that case, how much time and then money and efforts you're going to spend to maintain that stuff? So that's a question. So I'm saying that you should start thinking and designing everything from immutable point of view, everything. And then when you get to performance problems, which is going to happen later, when the product is ready and it works, and then you see it's a little bit slow here and there, or too slow here and there, then you jump into that place, you run the profiler, you see what's going on, and then you fix in some specific place. But not the other way around. Performance is less important than maintainability. That's my belief. Yeah.
About maintainability, let's say you have not 300 classes, but 300,000 classes, and you know, when you put a breakpoint and you look at the stack trace, it has like 100 classes until the top. Would your constructor suffer from any problems because of that?
We have many than 100. We have more than 100. We have more lines in the stack trace than 100. We have many classes, and that's good. That's perfect because all of them are small, and every time you see a problem,
what I'm saying is that you have to put all those 100 classes one below each other
in this big chain of instant. Yeah,
So
exactly. Well, it's not. I haven't seen situations with like 100,000 classes, of course, but in applications where we have like 300, 500 classes, it's perfectly all right. You don't put all of them in this long structure, but with the application, the higher level, when we have one big file, usually our applications look like one big file which creates everything, which constructs the big object, and then many small objects around. So we have like a few hundred small objects and one huge file which creates this very big composite object, and you only have the complexity at that level. So it's not really a complexity. As long as you get used to that, you will actually understand it way easier than procedural code. I can give you an example of the real later. You can come to me. I'll give you an example of the real project. A few real projects on GitHub. They're open source. You can see how they're designed, and you will see the code organized exactly that way. So all classes are immutable, and they have this composite structures in the beginning.
I had another question. Let's say you want to configure something like a database driver. So you want to be able to configure it. I mean, you don't want to couple the implementation of your database driver into your configuration class, basically like this, right? How do you solve that?
You mean you don't want to put the production data in there?
No, I mean the actual. Maybe I want somebody
The
to
password.
provide me. Let's say you don't want to write your own CSV parser. You want to inject some parser written by somebody.
Then
else.
you create a wrapper around this parser which you get. So you get
So
some
you have to wrap
all the stuff.
type of
Yes,
thing.
yeah, exactly, yeah. So if this stuff is coming to you from some library which is mutable, and they're thinking about the procedural approach when you need to new and then configure.
Maybe it's not mutable, but maybe it doesn't have a constructor. Which
Then you
takes
create your own
lines
class.
from
Yeah, you
it
create a
to
wrapper. Yeah, you create the wrapper or proxy or whatever. Just create something which looks. It's not going to be a problem. It's going to be small class, like a few lines. So you get this stuff from there. You know how to work with it, and then you create something which you will be able to use through the constructor in the right way. And that's okay because you basically isolate yourself from the code which is coming from somewhere else. That code is not perfect. It's mutable. We don't want to deal with that. We create our own piece, which is a connector between us, the good guys, and the bad guys. Right? Okay, one last question. Yeah.
So that you use only immutable objects?
Only.
Okay, and my question is, do you use that also for collections and
For collections as well, yeah. Collections are also immutable. So if it's a list, for example, then we create a list through the constructor, and then if you want to add new item, you copy, you make a copy, yeah, make a copy. That's why the question of performance. So of course, if you're dealing with a lot of data structures, it's going to be slow. Yes, it's going to be slow, and then you will have a problem. But in this case, you see exactly where it's slow, and then you change it to the mutability. But in most cases, what I see, it's not going to be a problem.
what do you do if you have two threads which want to access the same list? You want to add one thread the other.
If you want the list which will accept multiple items, then you create a mutable list. Yeah, if you need that functionality. But again, it's better to put this mutable list into some structure which is going to wrap this mutable functionality, and this structure will be immutable again. So it may happen, like you're saying, yeah, from the different threads you put some stuff in there, but in this case, just wrap this whole functionality, and this piece of code will look immutable to others.
So you can still keep dependency injection, but only by constructing.
Yeah, dependency injection through constructors only, of course. Yeah, of course.
Do you use Guava, for example, because Guava is known by the fact that calls inside it it's immutable and returns you collections, immutable collections,
Yeah.
and they build stuff like this with builders. So you have a builder, you add all the stuff, you just call it.
Yep, I use Guava a lot. Yeah, I like the library. I mean, it's good. It's a lot of procedural stuff in there, a lot of stuff which is not really good, but a lot of stuff which is good as well. So Guava is quite popular, and yes, I would recommend that. And they have immutable lists in there, immutable maps. They have a lot of immutable stuff in there, which is quite useful. It's not, again, it's not really perfect because Java is not designed to be immutable. That's the big problem. The JVM, they were designed in the C way, in the way of the C and C++. They were not designed with the mindset of true object-oriented programming at that time. So that's why we need to find these solutions. And all the languages which stay on top of JVM, they have these problems because JVM is not really for immutability. Maybe in the future there will be some languages and platforms who will be really about mutability. I believe, because this is the question of changing the mindset, of starting to think in immutable objects, not the procedural thing before. Because I put this on the same level. The procedural equals mutable. So if you think in immutable structures and mutable objects, you're thinking procedural way, and the procedural thinking is really bad. We need to think in an object way, where the object is not a collection of procedures and data attached to them. The object is something else. Object is a creature which you create and it lives its own life. It's not just something that you don't trust. In the procedural way, we don't trust our objects. We just think that they are just a collection of functions for us. We call the functions, there's some data in there, and we get the result. In object-oriented thinking, we think like that. We build an objects, we build them, we wrap them, we decorate them, and then now they stay in front of us, and then we say, okay, do something for us. Do something for me. In the very end, so there probably has to be like dot read or something. This is the last call to the whole big structure. Yeah.
How about Java 8? Does it change your approach about this?
But what? Dev?
Java 8.
Uh-huh. Java 8 exactly what? You mean the...
If you change this code like say in strings and a lot of maps transforming the lines from the input stream
for Java 8?
from Java 8.
For the stream, for the streams. Well, these streams are, that's a good thing. They're in line with that, so they're in the same direction, these Java streams. I mean, they're from functional programming. This is like a functional, this is the connection with functional programming and object-oriented programming. So it's good to use that stuff. They're not perfectly designed. That's probably a subject for another discussion in general. So I can't say I like the Java 8 in general, the direction they're moving, but they are definitely improving what we had in Java 7. So they're making the code way shorter. They're making the code more compact. They introducing the functional thinking to us, to programmers. But that could have been done in a little bit better way. But still, it's not really bad. It's a good direction in general, but not perfect in my opinion. But that's a different discussion. That's a big one. So I think Java 8 is not the perfect direction, unfortunately. Yeah.
And another short question. For example, if I'm a programmer, I would like to use this SCB library. For the first version, let's say battery written, I would have to find the receipt from Stack Overflow Hammer to instance the SCB reader and recall it. How would you document this so somebody can use it really fast?
You just document, the question is how to document these classes and how to explain people how they need to compose them one into another. Yeah, a lot of classes, yeah, so they stay away from each other, and then we need to find, that's a good question. So when we have the monster class, this is one class, there are 50 methods in that, you just open one class, you call them one by one, or you read the documentation in one piece, and you understand how it works. With the multiple classes, you have like 50 classes in front of you, right? Instead of 50 methods in one class. I don't have an answer. I don't know exactly how it should be done. So it's probably a question, in our libraries, it's a question, you need to know the library a little bit. I don't know how it should be documented. Maybe that's for the future. Because now at the moment we are used to have the documentation in one class. And that's probably why these open source libraries, they create these monster classes. Because they want people to use them, they want people to do it fast, they don't want people to think too much. They just want me to get this Java, Apache email library, and then immediately just one class. So I instantiate one class, it's basically a big procedural piece of code which I just call just one by one, and boom, my email goes out. That's perfect. In my case, in my library, you open the library, there are like 15 classes, and then 15 interfaces, and then another 20 classes. You just look at it, and you don't understand how to start. So I don't have an answer. Basically, maybe documentation, just some introduction, some maybe this.
How about a fluent builder?
Huh?
How about a fluent builder?
A fluent builder, that's also not a perfect thing, but in some cases we use that, the fluent builders. But these builders, they make classes too big also, like this, they're not so far from monster classes, because
but
these builders,
they create an immutable object.
in the end they create something
So
good,
it's a
yeah.
tool.
Yeah, so it's a tool. So maybe the builder is a solution, maybe, that's true, yeah. If you want to make your stuff more, friendful to the users, then you make the builder which they can start from. Because yes, so many classes, they need to read a lot of documentation to understand how to compose them one into another and what exactly which class is doing. So probably it's better for them to do it like that. You just make the reader and then set, they just click the dot and then boom, the IDE suggests all the setters. Perfect, I call this one, that one, that one. It works for me. Yeah, so I don't have an answer.
One dirty workaround is to write unit tests. Because
Write unit tests, yeah, write something. Maybe the way, I'm trying to change the way people think. That's why all these presentations, and that's why we're talking today now. So maybe people will start thinking that way. And then in the future, in a few years, they will open the library and they will say, okay, show me all the lists of classes and how they can be composed into each other. They're not going to be looking for one big monster class with 50 setters. They will be looking for, show me the structure I need to create. Show me how you compose your objects into one into another. And I'm going to do the same in my code. And then all libraries will, many libraries, more libraries will show that stuff. And then we will find some way to document that. I don't know. But now, unfortunately, we have that. Yes, it's easier to document. It's easier to understand for the procedural programming. But in the end, the code looks ugly. In the end, the code is unmaintainable. Because in the end, we have this mutability everywhere. We have this 2,000 lines of code in one class. And this is not what I like.
How
Yeah.
about Scala? That's the last one.
Scala is a good language, but I think if you want to know my opinion about Scala in general, I think it's a language which is going to be disappearing from the market in just 5 years, because Java is basically replacing, Java 8 is replacing most of the features which Scala introduced 5 years ago. So I think Scala is just, it was a good thing, it was a good product, but I think it's dying. It was good because Java didn't have the features Scala introduced, and like, for example, this functional programming. But now we have Java 8, and then we're going to have Java 9 soon. And Groovy is a good thing. Well, but Groovy is a different story. Groovy is a good thing, but Groovy is on the different league, so I think so. Groovy is more for, I don't know, yeah, it's for scripting language, and I think for smaller projects in general, because it's definitely, yeah, let's not talk about that. Okay, thanks. We're too much out of time. Thank you.